Hi everyone, welcome back to another episode of Startup Coding, where we continue building our Mafia game. So in this video, we're actually going to start the coding. We're going to work on the state shape and implementation, and then after that, we're going to work on the UX outline or the skeleton of the application. So in terms of the state shape and implementation, previously when we were going through our design of the data layout, we talked about creating that state shape. So that shape, it's actually underlying essentially the temporary storage on the user's device. And this is actually one of the most important parts because if you know what data you have, you also know what you can do. So for example, like if you want to go forward on a car, or backwards on a car, you don't really know how to do that or even what you can do, for example, how fast you can go, if you don't know your car. So in this case, knowing what data is underlying everything allows you to understand, okay, this is the data I have, and therefore with this data I can do X, Y, and Z actions. And when I do X, Y, and Z actions, I need to be cognizant of how to keep my data updated as well. So I'm going to go ahead and switch over to the actual coding window here. This is just a copy of the single player state. So as you recall from one of our earlier videos, we talked about this journey of creating a multiplayer component for the Mafia game. We already have a single player component, and I copied the same code over. This is mostly what's called boilerplate. And what boilerplate in programming means is essentially all the setup, all the templating in the code that you have to do, because that stuff is just kind of like the format of your product. You don't really need to memorize all of that because it's a lot of stuff to memorize for different use cases. So all you need to do is understand, I guess, what you're doing, why you're doing it, and what are the implications of it. And then the actual template, the boilerplate, you can just copy that in from somewhere else. So we copied this in from the single player game, and then we're going to modify it for the multiplayer section. So I'm just going to copy in the notes here from earlier about what data that we're going to have in the state. So to recap, we have the device ID, the name, the room ID, the leader name, the role, an array of the players and their status, and then the stage of the game we're currently at, and any local settings. So given that information, what functions do we need to have in order to be able to update this state? And by state, I just mean a local collection of data that's relevant to the current status of your app. So state is nothing too fancy. Essentially, it's just the same as storing variables on your computer. The only difference is that for state, it's related to the niche of data that pertains to what your application is currently at. So for example, if you're talking about variables about a person, you have their attributes, their age, their occupation, their current relationship, their past relationships. But if you're looking at the state of the person, it's what are they currently at? Are they currently sleeping? Are they currently awake? What's their current relationship? You don't really know about or care too much about the past or about other attributes that are not about the person in their present form. So same thing here. There are a lot of other data that we might be storing, but the state refers to the data that is the current status of what the app is doing. So we have device ID, we have name. So we're going to need something that updates the device ID. So we're going to add in a function here for update device ID. So we'll just call it mp update. Actually, we'll just call it update ID. Update device ID. You want your variables to be as descriptive as possible. And the reason for that is because for someone else who's reading your code, for example, you want them to be able to understand what you're doing relatively easily. So that's when that's called. And we're given the current state of the application, which is the current, I guess, status of these variables. And we're also given an action of what we're asking this function to do. So what we want to be able to update would be the current state. So let's just call it device ID equals to action dot device ID. Oops. So there are multiple conventions here where we have for the action. So typically we have the action, which is comprised of a text field. I'm just going to do that as a temporary thing. So we have an action, which is a text, for example, update device ID. And then we have a payload, which is the information that's related to that. So the payload would be, for example, in this case, only the device ID needs to be there. There's another convention, for example, if you only have a single variable, you don't really need a payload. You can just have that device ID there like this. And then instead of updating, accessing the variable in action.payload.device ID, you can just do action.payload and you're done. Because there's only one payload. Whereas in a more complicated scenario, so say for example, you're given a list of players, your payload might be you have a device ID, a player list, and then like another setting of theme. In this case, the payload object, which contains the an object of all the different payload variables, makes sense because you're passing in multiple payload variables, and it's all encapsulated inside that one payload object. But in this case, just for consistency, I like having this payload variable used because otherwise you're going to need a very, I guess, consistent rule of when do you have it as a variable inside payload and when do you have it as just the payload. You could do that, for example, if it's only one variable, then it's always just a payload. If it's more than one variable, then it's always an object, and a member item of a payload object. But I don't like that, I guess, differentiation. So we're going to always have the payload object, and then anything else will be accessed within that payload object. So let's just get rid of that other stuff. Actually, yeah, we'll just add to it. So we have the update device ID, then we have the name, the room ID, and the rest. So same thing with the name, we can just do this to be update name. Oops. And notice I have a console log here. This outputs to the console what usually get called. It tends to get very verbose in production, but for debugging, having these in there, I like it having it in there because in case something doesn't work or some data isn't getting updated, then you're able to see what functions get called, and therefore if the function gets called and data doesn't change, then it gives you a better idea of where the problem is. Whereas if the function doesn't get called at all, then you kind of know like, okay, the function's not getting called properly. So here we're going to have the state. We want the name to be action.payload.name. Now, for the rest of these, we're actually going to use a different format. For update stage, actually we'll do the same thing. So here we'll have MP update stage, update stage. And then here just we'll have stage equals to the new stage. So for these ones, we're essentially just updating one variable whenever these reducers are called. So it's fairly straightforward. It seems like a bit of overkill to even have this in a reducer function, but you'll see why we actually have this, I guess, convention in the next one where we're updating multiple state variables at once. So for example, if we're creating a new game, so in this case, we're actually updating multiple variables. We're setting the stage to be a default stage. So that stage will be, say, new game. We're updating the players variable to be the new set of players in the payload object. So action.payload.players. array of players already populated. So that's the public information about the game itself. We're also going to update the room ID that we're currently in. And then for the leader name, that's also populated in as well. So we'll just have that in there. Leader name. Role. So notice how we spent, I guess, a couple of videos in the beginning where we talked about designing all those different data objects and the overall layout of the game. Like all these notes, it seemed like, wow, we're doing a lot of writing before we even have the first line of code. Like, why do we have this much writing? Why do we have so much planning? And the reason for all of that is so that when we actually start coding, we know like, okay, we need to code functions for all these things. We need to take into account the data that we have, and in terms of the bigger picture of what the total game data is available. So all that planning is actually paying off now because you have a bit of a big picture overview of what you want to be able to create in your game. So that's why when we create this variable, it's actually just pretty straightforward. If we didn't do all that planning, however, we're going to be like, oh, okay, what happens when we create a game? What variables do we need to update? What variables are there to update? But because we did all that planning, it's fairly straightforward. So now we're talking about the role, the players, the stage, the local settings, and we pretty much covered all of it actually. So on this same vein, we're going to talk about what happens when we want to stop the game and what happens to the local state when that happens. So we'll just call it end game. So in this case, we just clear out those variables. Keep in mind that the room ID is actually the most important one because earlier when we talked about the notes, the room ID kind of determines what screen that we're at. So for the screen planning, there's the create a game, join a game in the game screen. How do we tell we're currently in a game, or versus we are not? If not in a game, we can create a game or join a game. So how do we tell we're currently in a game? If the room ID is populated. If the room ID is populated, yes, stage should be populated. Yes, players should be an array of players. Yes, leader name should exist. Yes, your role should exist. Yes to all those things. But the on and off for player for room ID is enough to tell you whether you're currently in a game or not. Because if you created a game or you joined a game, you have an active room ID. So we could just kind of leave it like that. And that pretty much is all we need to do. Because it doesn't matter if we have a player list of old players. As long as the game ID, the room ID is blank, you know that you're not currently in a game. And that player list should be just ignored. However, for cleanliness and for, I guess, good coding practices, we're actually going to clear out a lot of those things. So here we're just going to create an empty array. Does this really matter? No, it doesn't. Why do we do this? So that way, if we're accidentally accessing a variable and we don't expect it to be blank and it's blank, then we know, okay, something's up. The game didn't create properly. Whereas if we left those to be the last game's variables, even though in a ideal scenario, it doesn't really matter for us. Being able to access last game's variables in your current game by accident would still obfuscate some of the, I guess, debugging work and make it less clean. Plus, it'll keep a bit of extra memory space in your user's device. Not enough to matter, but, you know, just for good coding practices, we'll do that. So that's the kind of like the create a game and ending a game. So also we're going to want to be able to do some other things too. So for example, if you take an action, what happens? If you leave a game, you just call it end game. If you join a game, you can just do create game. So actually, in fact, instead of create game, I'm actually going to do join game here, because we don't need a different function to update local data for when you create a game versus joining a game. We can do that in the code itself, and therefore we can reuse this function for both, because think of it this way. In the case that we create a game on the back end, and then the game exists, so we can just join the game. If we're joining a game, we just join the game. So in this case, this is the same thing for whether we created a game or joined a game. The only difference is when we create a game, we also add creating a game on the back end as an extra step. So because of that, when we're updating the local state, we don't need to worry about that. We'll just have join the game. So now what can users do? So let's look back at our notes. Users are able to take certain actions. They can create a game, they can join a game. That's already covered in the create game. They can set their name for games. That's covered in our set name function. They can take role-specific actions during the game. They can end the game if leader or leave game if not leader. So these two cases are both in the end game state, because if you're ending the game for everyone because you're a leader, the game's over for everyone, but you're also leaving the room. And same thing if you're leaving the room if you're not leader. When you're leaving the room, you still clear out your current state. So role-specific actions during the game, we're going to talk about that. And this part's a little bit complicated. So what actions can users take, and what functions corresponding to those actions do we want in the state shape? Oh, and we should also have this initial state populated properly. So let's just copy this into there. So we have a device ID. So this is before everything's initialized. So we have it blank. This device ID should be initialized on game load. And then we have the stage. That one will be blank. Players will still be blank too. And then the room ID should also be blank for now. So we have device ID, name, room ID, leader name, so notice that I'm putting a lot of these room-specific variables underneath room. So that's just to kind of organize it, because if room ID is blank, these other things should also be blank, and they're kind of related variables. You shouldn't have a stage without a room ID, and you shouldn't have a players without a room ID, and you shouldn't have a leader name without a room ID, because if you're not in a game, there's no leader, there's no stage, and there's no players. Same thing for your role as well. So we'll copy that in. There. So all these are just kind of blank items. Notice that for players, it's an array. So we want to keep the typing the same, because otherwise you have to worry about checking for types when the players are empty. If it's a text versus an array, then that's additional complication. So we'll just make sure that we keep it the same type as what we're going to use it for, even though it's uninitialized, and we should never actually use players before it gets populated, after room ID gets populated. So now what happens when you take an action? So actually the better question is, do we need to update when we take an action? That's a very good point, and to be honest, we actually don't, because we don't do the action logic here. We do the action logic in the game code itself. So in terms of updating the data, we probably want something that updates this instead. So in this case, actually we probably want another one called actions taken. Sorry. So we want in the local state, we also have a Boolean for action eligible. And that's a true false Boolean variable, so that's essentially if you still have an action to take that stage. So in terms of you taking an action or someone else taking an action, what we need to do is update the player list. So this will be just equals to action.payload.players. And the question is, do we want to update players when players get updated, or do we want a way to update only when the next stage happens? So what that means is, in the game, players can take certain actions during a turn. Do you want the rest of the players to know about it after the turn's over, or do you want the rest of the players to know about it as the action happens? I think the second one, because there could be a case where, for example, there's multiple killers. If one killer kills player 5, for example, we don't want the second killer to also try to kill player 5. So in this case, we'll actually have update players and update stage to be two different function calls. Update given array of players, new status, and then update stage. This just updates the current stage that we're at and updates the user interface as appropriate. So we just have stage, cool. And then we need another one for action eligible. Action taken. In this case, we set the action eligible to false. We don't even need a payload there, because essentially when we take an action, we already know that since you're going to take one action per turn, you're automatically out of actions. And also when we update the stage, we want to refresh that option eligible to true. So see, that's the benefit of having all your variables available and also planning out your actions, so that way you know how they interact with each other. Because essentially, you need to know when to prevent users from taking action, and then you also want to be able to see when they're able to take actions again. So being able to refresh action eligible to true at the end of every stage means that for every new stage, the user is able to take another action again. Now, are there stages where users cannot take any action at all? For example, the killers during the police stage, they're not able to do any action, but that's determined on the UI side. Even though they can take an action, if it's not their turn, don't show them the option to take an action. So that's pretty much the main outline of what we need to do to update the stage shape. And we'll just remove these comments. So yeah, pretty straightforward and easy there. And it's a little bit boring, but this is actually the kind of the backbone of our data lifting in our app. The more fun part here is the actual code for the user interface and for, I guess, the game logic. Again, we copied the boilerplate from the single player mode. We had a working single player mode. We're now creating multiplayer mode. Since the screens are pretty similar, I just kind of copied in that boilerplate here. We're going to change a lot of this code, but the overall shape and outline isn't going to change as much. For example, when we first enter the room, we have, say, mpnav. We have home screen, we have a create game, and we have a game screen. So in this case, We have the create game again. That's actually another separate screen. We have join game, but join game doesn't need to be a separate screen because join game you only need a room ID and that's it. So the join game screen will be part of the home screen. And it is a stack navigator, so essentially it's a navigation interface which allows you to stack certain navigation windows on top of each other. So that way, if from home we go to create game, it loads the navigation of creating game on top of it. So that way you only see the created game until that's done with. And then when that closes out, it gets rid of that window and then you see back to the home screen. And then same thing if we're in the game window, it creates the game UI stack on top. You only see that until it gets done and over with, then you remove that, you get back to home. So in the home screen, in the single player mode, we had the create a game, we had a resume game, we had a join game. There's no resume game here because for the single player mode, the reason why we resume game is because when you close the app and reopen the app, do you want to go back to your old game or do you want to go to a new game? That's why that's there. But because this is the, I guess, resume game function, I mean, there's multiplayer. When we resume game, we just go back to the same game room that we're currently in. So in this case, we just rejoin the game and it goes to the game. Otherwise, if you want to create a game, it goes straight to there. And then we also want a separate section called join game. Which normally is blank if you already are currently in a game, but if you're not in a game, the join game is going to give you the option to join a game. So we're going to have the join game here. And then we're going to have a couple of text fields as well. So I'm going to copy in the code for the text fields, which we can just actually find over here. I believe it's called input. Actually, let's see what we have there. Give me 1 second. Yeah, it's called input. That's an object for just the text input box. So let's go down to here and we see, where do we have some existing code. So notice that when we're using when we're doing a lot of programming, we actually try to reuse what code we already have. So instead of thinking like, okay, what's the syntax for input text field? What parameters do I need for it? What do I call it? I just copy it from somewhere else, and then that way we have that available. So we'll just kind of add that in. When we're joining a game, we have a couple of fields that we want to update. We have an input box. And then let's see. So notice that we have a player name here. And we'll just delete this. We don't need a current value, will be just name. And then on change will be just update name. Text. And we need to wrap this all in a view. And for React for Web, we're essentially just using a div, but here we just use the view instead. So we have a text field for the player name. And then we also want the room ID as well. Notice that for the name, it's the same. We want this name box to show up regardless of whether we're creating a new game or whether we're joining a game. So we're gonna actually move this out of here. Oops. We're going to move this out of here into display. And we're going to wrap this in the view as well. There's something called React Fragment, where if we don't necessarily want a view, we just want to kind of wrap multiple components together, we can use that as well. But just for, I guess, personal habit's sake, I'm just going to use this. And then just update the spacing. So in this case, what's going to happen is, if we're currently inside of a game, say sp.roomID. So this is what we were saying earlier about if the room ID exists, that means that there's currently a game that's going on. If it doesn't exist, then there isn't. So we're using this to determine whether we're in a game or not. And it's all based on just room ID. And because of this line of code, we're actually not showing this rejoin game button because it goes directly to the game. So now we have, however, we're not currently in a game. We want to be able to create a game, or we want to be able to join a game. In both cases, we want to have, let's take out this create a game. We want to display the name, so the user's name that can be updated and changed. And then we can allow them to start a game, or we can allow them to join a game. But either way, the name is required. So here we have the display. I'm just going to do two things where we have display and join game. So notice that these are local state variables, so we're actually going to use use state for local state. And we'll just create those variables here. We have a redux state, and then we have the local state. In this case, we're using name, set name, and we're using room ID and set room ID. And the default for these will both be blank and blank. So this way, when the user opens this section of the app, multiplayer, if they're currently in a game, it'll just direct them directly into the game. If they're not currently in the game, it's going to show them display and join game. Display being the player name and starting a new game, and then the join game being the option to also enter a room ID to join the game. But either way, the player name is required, so that's why it's kind of up top here. So that's the starting screen. So let's go back to our notes. From the notes side here, we have several items on the user actions and the backend actions, and then the screen planning. So the starting game, we have edit their name, which is what we have. With the create game button, we have the room text box, with the join game. We should probably add in a status text area for whether the game joins successfully or not. Normally that's handled probably with pop-ups, but the status area is also pretty good for in case you want to do it for web. In that case, the same React Native components that are for pop-ups on a mobile app are not the same ones that are for web, which is just an alert box. So having this actually makes things a little bit more flexible. So we're going to add that in now. MP, and then we're going to have like a little status text here. For status, set status, and it's blank. So by default it'll be blank, but eventually if we need to show the status, we have that status that's available here. So for example, if they can't join a game, or if the name's already in use, or if the room ID is incorrect, it'll all be there. So that's it for the first screen. Since we're actually heading up to half an hour, we're going to save the other screens for the next video, which will come either tonight or perhaps another time, but probably tonight. But either way, hope you liked the video. Click that subscribe button. Drop any questions you have in the comments, and look forward to seeing you in the next video.